Okay, today we are factoring what's called special cases. Okay, for these special cases, there are three special types of binomials that we'll be factoring today. The first one you saw in Algebra 1 is called a difference of squares. In order to have a difference of squares, first of all, you have to have a subtraction symbol in the middle. And then the two terms in the binomial have to be a perfect square. So at the top of the paper of your notes handout, you have some blank space. And I want to make a list of perfect squares in that blank space. So in order for a number to be a perfect square, when you square root it, it's going to be a whole number. So what is 1 squared? 1 squared. 1. What is 2 squared? 4. What is 3 squared? 9. What is 4 squared? 16. What is 5 squared? 25. What is 6 squared? 36. What is 7 squared? 49. 8 squared? 64. 9 squared? 81. And 10 squared? 100. And I'll put dot, 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 because that would continue. But there's the first 10. And all of those are perfect squares because if you square root them, the answer is a whole number. Okay, variables can also be a perfect square. In order for a variable to be a perfect square, their exponent has to be a multiple of 2. So that could be x squared, x to the 4th, x to the 6th, x to the 8th, I'll put a dot, dot, dot. That pattern continues. The variables are perfect squares if their exponent is a multiple of 2. So 2, 4, 6, 8, 10, 12, keep going.
So just an even number?
Just an even number. Okay, so let's factor some differences of squares. So again, this is a review from Algebra 1. Okay, so number 1, we need to check to see, is it a difference of squares? So first of all, is there a subtraction sign in the middle? Yes. Then you have to check your two terms and make sure both of these terms are perfect squares. So is x squared a perfect square? Yes. Is 9 a perfect square? Yes. So to factor this, our answers are going to be two binomials. So go ahead and put your two sets of parentheses. And to find out what goes inside the parentheses, we're going to square root both of these terms. So when you square root a variable, you just cut the exponent in half. So instead of x to the second, half of 2 would be 1. So x to the first, x to the first. One is a plus, the other is a minus. And square root the last term. What's the square root of 9? 3. So notice the answers are very similar, except one of them is a plus in the middle, the other one is a minus. So x plus 3, x minus 3. Next one, number 2. We have x squared minus 1. First of all, we have to check to see, is this a difference of squares? So do we have a minus in the middle? Yes. Is x squared a perfect square? Yes. Is 1 a perfect square? Yes, it is, because the square root of 1 is 1. So go ahead and put your two sets of parentheses, and to find our answer, we need to square root both of these terms. So the square root of x to the second is x to the first. One is a plus, the other is a minus. And what's the square root of 1? 1. So we have x plus 1 and x minus 1. Number 3, is this a difference of squares? Yes, it is. So go ahead and put your two sets of parentheses. And now we need to square root these. So what's the square root of 36? So we'll have a 6 and a 6. What's the square root of x squared? X. We'll have a 6x and a 6x. One is a plus, the other is a minus. And what's the square root of 121? 11. So I have 6x plus 11, 6x minus 11.
Ain't it a way to, you put the square roots in the back, like,
Could you put those square roots in the calculator? Yeah. So for square root, you'll need to do control x squared. So if you wanted the square root of 36, do control x squared, and square root of 36, you get 6. Next one, number 4. Is this a difference of squares? Yes. So put your 2 sets of parentheses. And to find our answer, take the square root. So what's the square root of 49x squared? So we'll have a 7x and a 7x. One is a plus, the other is a minus. And what is the square root of 16? 4. So 7x plus 4, 7x minus 4. Number 5, is this a difference of squares? Yes. Put your 2 sets of parentheses. What's the square root of 4a squared? 2a, 2a. One is a plus, the other is a minus. And what is the square root of 81b squared? 9b and 9b. So we'll have 2a plus 9b and 2a minus 9b. Number 6, is this a difference of squares? Yes, so put your 2 sets of parentheses. Square root of 16 is 4 and 4. When you square root a variable, you cut it in half. So what's half of x to the 4th? X squared. So we'll have a 4x squared and a 4x squared. One is a plus, the other is a minus, and the square root of y squared is y. So 4x squared plus y, 4x squared minus y. Number 7, is this a difference of squares? No, so this is called prime. Why is this one not a difference of squares? Yeah, that's an addition symbol. In order to be a difference of squares, we have to have a difference in the middle. So we have no such thing as a sum of squares. So this one is called prime. This is the most commonly missed question on our Unit 4 test. So on Tuesday's test, do not miss this question if you see something similar to it on that test Tuesday, and you will see something similar. So if it's a plus sign in the middle, the answer is prime. Number 8, is this one a difference of squares? No, because it's 2 a perfect square? No. So if it's not a difference of squares, look for a GCF. So what is the GCF? 2. So factor out the 2. And 2 times what gives us 2x squared? X squared. And 2 times what gives us negative 8? Yes, now looking inside the parentheses. Now do we have a difference of squares? Yes, so bring down the 2. That's going to be our first answer. And now we need to factor our difference of squares. So square root the x squared. What's the square root of x squared? X. So we'll have an x and an x. One is a plus, the other is a minus. And what's the square root of 4? 2. And I'm running real slanted, but it's 2x plus 2x minus 2. And number 9, is this one a difference of squares? No. Look for a GCF to see if we do end up having a difference of squares. So what's the GCF here? What was the GCF? 3. So 3 times what gives us 12x squared? 4x squared. And 3 times what gives us negative 75? Negative 25. Now, look inside the parentheses. Now do you see a difference of squares? Yes. So bring down the GCF. That's our first answer. Then we'll have our two sets of parentheses. Square root these to find our answer. So what is the square root of 4x squared? 2x. So we'll have a 2x and a 2x. One is a plus, the other is a minus. And what is the square root of 25? 5. Don't forget that GCF needs to be included in your answer. Any questions on the front? Okay, on the back page. Now we are going to be looking at the sum and difference of cubes. So the first thing we're going to check or write down is what is a perfect cube. So a number is a perfect cube. Oh, we have one more. You do number 10. So before we go to the back, you do number 10. We'll check your answers in a minute. So you do number 10. Okay, the first thing you need to check, is this a difference of squares? No, 2 is not a perfect square, neither is x cubed. So look for a GCF, and what is the GCF? 2x. And inside the parentheses, you should have had x squared minus 49. And looking inside the parentheses, now do we have a difference of squares? Yes, so bring down the 2x. Your GCF needs to be the first answer. And for the binomial, square root these, what's the square root of x squared? So I have x and x. One is a plus, the other is a minus. And what's the square root of 49? 7. Make sure you have all three answers, including the GCF. Now we're ready for the back page. And on the back page, we're doing sums and differences of cubes. So the first thing I want to do is write down a list of all of the perfect cubes. So a number is a perfect cube if you can cube root it, and the answer is a whole number. Not perfect square, these need to be perfect cubes. So perfect cube. There's a perfect cube if you can cube root it and the answer is a whole number. So what is 1 to the third power?
1.
Yeah, if you did not know that, how would you, 1 to the third power, you could do 1, up arrow, 3. So 1 cubed is 1. What is 2 cubed? 8. What is 3 cubed? 27. What is 4 cubed?
64.
64. What is 5 cubed? 125. What is 6 cubed? 216. What is 7 cubed? 343. What is 8 cubed? 512. I'll to say dot, 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 because those are getting pretty large pretty fast. Now, a variable can also be a perfect cube. In order for a variable to be a perfect cube, its exponent needs to be a multiple of 3. So like x to the third, x to the 6th, x to the 9th, x to the 12th, etc., etc. Okay, on the back page, we're going to be using the bottom two formulas. Either it's going to be a difference of cubes or a sum of cubes. So for cubes, you can't have an addition symbol in the middle. So looking at number 11, we need to figure out, do we have a difference of cubes or a sum of cubes? Sum of cubes. So this is the formula we're going to be using. Well, first of all, is x cubed a perfect cube? Yeah, is 8 a perfect cube? Yes, so this is a sum of cubes. So I'm going to first step write down that formula. A plus b for the binomial. For the trinomial, it's a squared minus ab plus b squared. You don't have to memorize these formulas. For our test Tuesday, you'll have a formula sheet with these on it. But you do have to know how to use it. Okay, for the difference of squares, to find our answers, we took the square root. So if I have a sum of cubes, to find my answers for A and B, I take what's called the cube root. So we need to cube root x cubed to get the A value, and we need to cube root the 8 to get the B value. So both of these take the cube root. When you cube root a variable, you divide the exponent by 3. So cut it into a third. So it's 3 divided by 3. 1, so this would be x to the first. And the formula shows a plus sign in the middle. And to get the b value, we need to cube root the 8. So cube root of 8 is 2. If you want to know how to put that into the calculator, for cube root, hit this button by the 9. So we hit the button right here by the number 9. And if you want the cube root, you need this one that's selected in blue. Notice it has this extra box over here by the radical symbol. And that's where we're going to type in the third root. So just to check to make sure, we're looking for the third root of 8. And the cube root of 8 is equal to 2. There's other ways you can do it on the calculator as well, but that's one way you can do it on the calculator. How do you do it by hand? You just have to think what number to the third power equals 8. So that would be 2.
Oh, wait a minute.
You have a question?
Nah, I was very well.
Okay, now we're going to take these numbers for A and B and fuse them into the trinomial formula. So for the trinomial, we need to take the A value and square it. So looking at my binomial, the A value is x. So if I take x and square it, that gives me x squared. Then the formula shows A minus. Then it shows AB. That means A times B. So for AB, we need to multiply the x and the 2. So what is x times 2? 2x. And it has to be A minus 2x because the formula shows that the second term of the trinomial should be A minus. Now, the last one in the trinomial is always a plus. And we need to take the b value and square it. So if the b value is 2, we need to square this 2. And what is 2 squared? 4. So here's our answer. For the binomial, it's x plus 2. For the trinomial answer, it's x squared minus 2x plus 4. Next one, number 12. Is x cubed a perfect cube? Yes. Is 27 a perfect cube? Yes. So is this formula going to be the difference of cubes or the sum of cubes? Sum of cubes. And the formula, off of the formula sheet you'll be given next week, is a plus b for the binomial. For the trinomial, it's a squared minus ab plus b squared. To find a and b, we need to cube root both of these. So for x cubed, what is the cube root of x cubed? X. And then we'll have a plus sign. And now for that 27, you said the cube root for 27 is 3. 3 cubed, 50, 27. Now, use these two numbers for the trinomial. So I need to square the a. If I take x and square it, that gives me x squared. And then bring down your minus. AB means a times b. So I need to multiply x times 3, and that gives me 3x. And the formula shows this should be a minus 3x. And the formula also shows that the last term should be a plus. Now I need to take the b value and square it. So if b is 3, what is 3 squared? 9. So our answer for the binomial is x plus 3. For the trinomial, it's x squared minus 3x plus 9. Number 13 is 27 a perfect cube. Yes. Is x to the 6 a perfect cube? Yes. Is 64 a perfect cube? Yes. So is this a difference of cubes or a sum of cubes? Sum of cubes. So the formula is a plus b, a squared minus ab plus b squared. To find a and b, we need to cube root both of these. So what's the cube root of 27? 3. And when you cube root a variable, divide it by 2. So what's 6 divided by 2? 3. So this would be x cubed. And then we'll have a plus sign. And for the b, we need to cube root the 64. What's the cube root of 64? 4. Now, a needs to be squared. So 3, what was 6 divided by 3? 2. This should have been a 3x squared. 6 divided by 3. When you cube root the variable, you divide the exponent by 3. So 6 divided by 3 should have been 2. Now, I need to square the a. So if a is 3x squared, I need to square that. So what is 3x squared times 3x squared? 9x to the 4th, and then a minus sign. What does AB mean? A times B. So we need to multiply 3x squared times 4. And what does that give us? 12x squared. So minus 12x squared. And then a plus sign. And now the 4 needs to be squared. And what does that give us? 16. So for the variable, when you take the cube root of a variable, divide the exponent by 3.
Really, I have 25.
Okay, number 14. Is this a sum of cubes or a difference of cubes? Difference of cubes. So the formula is slightly different. So for the difference of cubes, notice the main difference is that the plus is now a minus in the binomial, and the middle term in the trinomial, instead of a minus, it changed to a plus sign. So the formulas look pretty similar, It's just the signs change in two places. Okay, so the formula is A minus B, and the trinomial, everything's positive. So this is A squared plus AB plus B squared. Now we need to cube root both of these. So what's the cube root of x to the third? X. Then the minus sign. What's the cube root of 216? 6. Now we need to square the x. That gives us x squared. Now this time it's a plus sign. What does AB mean? Multiply A times B. Notice A is x, B is 6. We don't even look at the minus sign. So we need to multiply just the x and the 6. And what's x times 6? 6x. And the formula shows that there should be a plus 6x, not a minus. Make sure it's a plus. The last term is also a plus. And now the 6 needs to be squared. And what is 6 squared? 36. So make sure the signs in your answer match the signs in the formula. So these should be a minus, these should be a plus, these should be a plus. So make sure your signs match the formula. Number 15, is this a sum of cubes or a difference of cubes? Difference of cubes. So the formula is A minus B, and a trinomial, everything's positive. A squared plus AB plus B squared. Take your cube root. So what's the cube root of 64x to the third? 4x. Then the minus sign. What's the cube root of 1? Cube root of 1 is 1. Now, 4x needs to be squared. So what is 4x times 4x? 16x squared. Then a plus sign. What does AB mean? Multiply. So we need to multiply 4x times 1. That gives us 4x. And the formula shows there should be a plus for the 4x. And then another plus sign. And we need to square the 1. And 1 squared is 1. Yes.
Can you think of it like the one the opposite? Just like people to be more than negative.
Yeah, you can think of it like that. Number 16, is this a sum of cubes or a difference of cubes? Difference of cubes. So the formula is A minus B, A squared plus AB plus B squared. What is the cube root of 125A cubed? 5A. Then the minus sign. And what is the cube root of 8B cubed? 2B. Square the 5A. What is 5A times 5A? 25A squared. And then a plus sign. What does AB mean? A times B. So what is 5A times 2B? 10AB. Then a plus sign. Now the 2B needs to be squared. So it's 2B times 2B. 4B squared. Number 17. Is this a difference of cubes or a sum of cubes? Neither one, because it's 5 a perfect cube? No. So what do you think I need to do? Factor out the GCS, so factor out the 5x. And inside the parentheses would be x cubed plus what? 8. Now look inside the parentheses. Now, is this a difference or sum of cubes? Sum of cubes. I'm going to write down the formula so the GCF goes first. The formula for a difference of cubes is A plus B, A squared minus AB plus B squared. GCF goes first, so bring down the 5x. What is the cube root of x to the third? X, then a plus sign. What is the cube root of 8? 2. Square the x, that gives us x squared. Then the minus sign. What does AB mean? A times B, so what is x times 2? 2x. Then a plus sign, and 2 squared is 4. And the last one, number 18. Is this a difference of cubes? No. What do I need to look for? GCF. What's the GCF here? 2x squared. And inside the parentheses would be x cubed minus 8. I want you to finish number 18. Okay, the GCF should be your first answer, the 2x squared. When you cube root x cubed, what does that give you? X. Then a minus sign. What is the cube root of 8? 2. Square the x. That should have given you x squared. Then a plus sign. What does AB mean? Multiply. So x times 2 would be 2x. Then a plus sign, and the 2 squared is 4. Now, one more thing before you throw in your assignment. Your assignment is not going to have differences of squares first and then difference in sums of cubes last. They're going to be mixed up. So you'll have to do a little bit of thinking. So let's say I have x to the 6th minus 16. Is that a difference of squares or a difference of cubes? Is 16 a perfect cube? No, so it's not a difference of cubes, it's a difference of squares. So you have to be very careful because this is a multiple of 3, but it's also a multiple of 2. So you have to be careful. What if I had x to the 4th minus 64? Is that a difference of squares or a difference of cubes? Squares, because it's 4 multiple of 3? No, so just be very careful on your assignment.